Hi, so welcome to Group 15's presentation for Project 2. It was a project that involved taking the Yelp dataset, narrowing it down, and then creating a web interface using Flask and the Jinga templating to create a user interface that the end user can use to query and basically provide the city, cuisine, day of the week, and time that they wish to visit a restaurant, and we should return to the user a relevant restaurant and perhaps some other restaurants. So I'm going to take you through. This is our general design for the web page. This is the landing page that the user's greeted with. Looks really good. If they scroll down, it suggests that we can you can input your details and we'll spit out a restaurant. And then it takes you to the input form. You select a city, you select a cuisine, and you select a day of the week, and then finally a time, and then you hit submit, and it returns a restaurant. Images up here, name of the restaurant, address, the rating that it got, how many reviews, the review, the person that actually reviewed it. It just gives you a rundown of what your input actually was, and then it suggests 5 other restaurants, well, hopefully 5 if they are available, that are both open in a similar area and a cuisine. So now I'm going to talk you through how we managed and isolated the data that we chose. We first designed a schema, so we decided, okay, the business would be the central point. It would then be placed within a category, and the business might have photos attached to it, but the key thing was that a user would review a business, and users could obviously be friends with other users. The review relationship actually hosted all the review details, so all the text was hosted here, so we didn't use like a separate node just for the review. We actually hosted it in the relationship. So moving on to how we actually chose our data. So I went onto Wikipedia and got the top 14 most populous states in America, and we decided that we would isolate based on that. We threw in Arizona just because the data set also had a large population in Arizona for some reason, so we added them to the list of states. We used the tool provided to us by David Effendi. We thought it was quite useful. It had a lot of stuff that would have just been mundane, so we used a lot of that code. It was a good jumping off point, but obviously we had to include a lot more stuff. We had to include the times for the days of the week. We also isolated data according to whether or not a business was open. So if a business wasn't open, we didn't bother adding it to our data set. And we also only added businesses that were restaurants. So if a business wasn't added to the restaurant category, it wouldn't be added to the data set. So basically we had 3 main criteria. It was in the relevant states that we had selected, whether or not a business was open, and whether or not it was a restaurant in the first place. That did have some problems because the Yelp data wasn't the cleanest. So we'd have like car washes that were tagged as restaurants, and that's just down to, I think, the data being slightly dirty. But we went through manually and removed those, just so that it didn't mess out with the data. But this is the most automated way of us going through, I think, 16,000 businesses. Then to actually import the data, we used another one of David Effendi's tools. This was the one that made use of the APOC plugin. This allows us to create the relationships as we're importing them into the database. Also, again, made our lives a lot easier, but again, not everything was there. So one of the main things that wasn't there were photos. So we manually added the photos after the fact, using a similar methods to what he used. But yeah, so it was a good jumping off point, but obviously a lot of work still had to be done here and there. So as I mentioned before, we had a decision to split the group into two teams of three. Um, 3 people worked on the front end, 3 people worked on the back end. On the back end side, we decided that we'd create method stubs, basically convenient methods that front end could obviously call to get data back from the database. We used the graph extension that comes with Py2Neo. That made it convenient to write queries as you would when you're using the browser. And then here you can see these are the methods we made. They get the hours, get whether or not the business is open, find the most useful business. Later on we found things that we needed, so we needed review counts, so we got that from the database, as well as getting a list of the photos that front end could then use. This allowed us, the fact that we'd split it up obviously allowed us that it was very compartmentalized, so we could chop and change, move things around without breaking too much of the code. We actually never had a situation where the entire code base went down because something had broken. It was always easy to find errors, and things didn't stay broken for very long at all, which was really comfortable to work in. But yeah, even here you can get the date and whether or not a photo is valid. So we found photos actually gave us a bit of trouble. The Yelp photo set didn't have all the photos, so we had to use a combination of that photo set as well as the web API, so using the address to get the photos. Yeah. Moving on, we used unit tests to create test cases for our Python methods. These are the methods that front end would use to get back data. So we manually inspected the database, got back expected input, and then made assertions. You can run the test cases by using Python 3 flag m unit test _main.py. You run it, you should get, yes, so all the test cases have passed. These query the database, make sure that the input matches the output, so we make assertions. So if I bring over the test file, we've tested it for each method we've made, so get top 5 businesses, and we've gone and checked obviously what it should be for a given input, and then ensure that the data that gets returned matches that. Our test cases also check that the data is sorted correctly according to stars, and also breaks ties where relevant according to the spec that was given to us. So we assure that the user is getting the optimal restaurant when they're querying the database. So on the front end side, we used Flask and Django templating to input and output data using post requests. We as well incorporated CSS elements into our HTML. This gave our website a really nice design. We also used template inheritance, which allowed us to create elements in the base HTML that could be used across all the pages that inherit from it. We also used Bootstrap and Materialize frameworks to help create the actual design. So Bootstrap was mainly used to make the website responsive by adding containers and rows. This kept everything aligned and in the right places at the right times, as well as using Materialize to help us incorporate this parallax effect that you see while scrolling. Bootstrap also allowed us to make the web page adapt to different screen sizes. So if you visit the URL with the port number on a mobile device, the web page will readjust and work with multiple device sizes. Lastly, we just wanted to show an ideal situation. So we used Charlotte fast food Saturday and 4 o'clock as our inputs, and this is sort of an ideal scenario. So it has all the relevant information as before, but all these restaurants all have the same cuisine, the opening times are all relevant, and they're all within a certain radius in the area. Whereas before, if we didn't have 5 restaurants to give, we'd usually find another method, such as using stars or usefulness of reviews, to fill in the 5 restaurants. So that's how we achieved that